today is before we proceed, we kindly request you to silence your phone and refraining from using the flash photography in this session. This session will last 45 minutes and it will be recorded and it will be available online in a few weeks. Our guest will be open to questions. We encourage you to raise your hand for questions, and we will facilitate a Q&A session to engage with the speaker directly. It is both a privilege and an honor for me to introduce our guest, Robert Hodges. Robert is the CEO of Altinity, and an enterprise provider for the ClickHouse, which is an open source column-oriented database management system for real-time data analytics using SQL. Robert will be talking about Kubernetes data security. Without waiting any longer, I'm excited to give the floor to our guest. Let's welcome you.
I want to say a huge shout out to DataCon LA. This is a wonderful conference. I really appreciate all the work you guys do. Thank you. All right, let's dive in. So I'm going to be talking about Kubernetes data and security and how you can sleep well at night. Hopefully not during this talk, actually. So let me dive in. I do have intros here, but they were pretty weak. Let me talk about the stuff that wasn't on the bio. So first of all, I've been programming now for 52 and a half years. So it's been a while. This was when I first started. The way you would boot a computer up is you would turn it on, and then you would get a stack of cards. You would take them over to the card reader, put them in, and punch the button to start the initial program load. So things have changed. Nowadays, we have big conferences, they have DJs last time. So it's really changed. I think the big thing is if most of you don't look like students, but I know that one of the things that's really key is just to stay curious. I'm actually not a CS person, but the company that I run is called Altinity, and we're a service provider for ClickHouse. But the most important or most relevant part is we do a lot of work on Kubernetes. We have a cloud for ClickHouse. It's on Kubernetes. We've got hundreds of clusters, and we've also done a lot of work with operators, which is something we're doing. So I'm going to start really basic. What's Kubernetes? So it's an orchestration system. So what's a container? If you've ever done Docker run. So they're a very popular way of packaging applications in a way that you can run platform and host independently. So it's a very, very powerful way of running distributed applications. And what I'd like to do is just explain a little bit about how it works. So I showed a picture, very simple picture of a database, MySQL talking to some storage. Here's how Kubernetes represents that. You see this, you see the pod, you see the, well, I think all stateful set, that's a resource that has storage attached. You have a pod that actually maps down to a process running somewhere in the You then have persistent volume claims, which are a request for storage. And I think all persistent volume fulfills it. And what Kubernetes does is it will map these down to the resources necessary to make this reality. And this is just a simple example to show how it works. But what's interesting about Kubernetes is it does scale. So you can have hundreds of resources, running dozens of hundreds of processes. And Kubernetes will manage them, it knows how to upgrade them. It can run across different cloud platforms, so on and so forth. It's a very powerful system. So as a result of those properties, it's really great for running databases because databases turn out nowadays, modern databases are increasingly complex. So what we see is more and more data moving from traditional, like running in a Lactose or something like that, to running up in the cloud and then orchestrating the problem is, and this is the whole theme of this talk, is if you have data up in the cloud, if you have data anywhere, you have to protect it from attack. So that's what we're going to do. Let's dig into it. So when you actually look at Kubernetes, it has all these little pieces. As you start to think about security, and you look in at the details. So it's an example of what we might call a multi-dimensional problem. And security is just one of those problems that doesn't have one simple answer. In fact, it's a whole checklist of things you have to think about. They occur at different levels. They occur, sort of in different ways on different platforms. So as you go down at the ground level and start to look at this, you need some orienting principles that will help you tackle. So we're going to do away with that picture and start with something much simpler. So one of the ways that you can think about protection of data on Kubernetes is to divide it up into two ways. One is to protect the database application itself. And we're going to spend most of the talk on that because that's where a lot of the interesting complexity is. Then you got to think about Kubernetes, because that's the bin that you're running. So you want to protect that. And finally, and this is something that people sometimes don't always think about, is it turns out modern databases tend to ship data out to other locations. So we're going to dive in and look at each of these. So the first thing is we go into the database. Yes, that's part one. Yes, that's simplifying. But as you start to look at the details, especially like the data warehouses that we run, for example, we have, like in our cloud, one that we were working on earlier this week had about 20 servers. Each of them has, say 20 terabytes of attached storage. It has a bunch of resources. It's still a pretty complex application. So the first thing we need to do, and this is like just a really basic engineering, and in Kubernetes, one of the reasons that Kubernetes is so great for managing data now is because of something called operators. So how many people here have used operators? Got two, got three. Okay, most of you have not. Let me tell you what they are. So, when I showed that picture just a few minutes ago, I showed these resources like stateful sets, like pods, which represent processes, so on and so forth. What operators do is they allow you to define new resources. So you can define a resource and you can call it MySQL database. And then the operator, it provides that definition. Moreover, the way that you program Kubernetes is you send it these resource definitions. So you'll have for example, a MySQL database resource definition. It's declared to Kubernetes. And when Kubernetes gets it, it will go find the operator responsible for managing that type of resource. It'll hand it the document. The operator can look at it, and it basically turns it into reality. It allocates other resources inside Kubernetes. So this is kind of an event-driven pattern on a grand scale. It's a very fundamental way. It's sort of this fundamental pattern that works throughout Kubernetes. So you start with a bit of YAML, you go to Kubernetes operator, and then you get some resources. Here's actually the mechanics I just described. So it's a custom resource definition. It's pushed into use a program called kubectl. Normally I do a demo at this point to show it, but you just push it in, it gets handed to the operator goes out and looks at what's out there, and then it does reconciliation. So in the case of MySQL, that example is so simple, I could have just programmed it myself. I could have just written the resources, but if I've got dozens or hundreds of resources, that's where operators are being. So what you see here is something more like what we deal with these data warehouses, where the definitions, it might be, say, 24 inches of YAML, but it then ends up describing a system that has dozens and dozens of resources. If it's backup, has maybe 4 dozen storage volumes allocated on EBS. It's quite a bit of stuff. So this is just a huge win. One of the cool things about it, besides simplification, is that database operators now include security features. So here's an example. I'm going to use ClickHouse examples because those are easy for me to find. And we work with them every day. But most operators look kind of like this. It's a YAML file. You see something that says ClickHouse installation. That's the name of the resource, so that Kubernetes can associate with the correct operator. And then there's a bunch of other settings in here. So for example, you can see, actually, you can see that it's defining users, like with passwords. So what this is doing is locking down the default user. There's even a rule in our operator that it will only allow that that account to be used from IP addresses that belong to it. So you get this locked down. Other things we can do is, because we're a cluster and we have communications between hosts, we'll automatically secure those as well. So without doing anything special, just by configuring this, writing a few lines of YAML, you're already getting some basic protections. So we can build from there. So one of the things that that example showed is that we're showing database passwords. So they were, in that particular example, they were SHA-256 sums, so they're not really easy to reverse. But the point is, they're just lying around for people to look at, maybe take them home, have a quiet dictionary tap session. What we'd like to do is start passing this stuff around. It's a little bit more secure. So we have operators. The next interesting resource or tool that Kubernetes gives us is secrets. So this is actually a really cool feature, because if you look at databases, they have all kinds of different. So it's not just, it's obviously simple things like, hey, the logins for people that are going to log into the database. But databases talk to other databases. Databases nowadays tend to talk to object storage. It's a very popular place to put data. Databases talk to Kafka. So what you find is the database just has all these credentials in it, and we need a way to get them in safely. So Kubernetes gives a really simple resource, which, as I mentioned, is this thing called a secret. So it's basically, and I'll show you a definition, but the idea is you can create these, and then there are ways of attaching them to a pod so that the process can actually see. Let's show it again. So if I want to, for example, set the password on my account on ClickHouse, I can actually define a password, or excuse me, a secret. And it's this secret is given a name. It's the resource has a name, and then it has a field in it, or a key in it called root login, and that is going to contain the password for my account. So if I set it up like that, in our operator, it knows about secrets, and you can use some specialized syntax, as this example shows. And what this will do is basically suck that value in and supply it, correctly configure it inside the pod so that user now has the password. So that's basically taking care of a really important problem, which is, how do I get these passwords in a safe way? Moreover, if I change that secret, like if I want to change the password, all I have to do is go edit that secret, reapply it to Kubernetes, and the operator will pick it up and make it happen inside the database. So this is a way to supply this secure data. So this particular example that I'm showing you depends on the operator to understand what secrets are. Kubernetes itself, though, gives general ways to process secrets. So how many people use Amazon? Okay, you know about secret keys and things like that. So one of the things we might like to do is tell this database or this database server about our Amazon keys so it can talk to objects. Here's an example. So what we can do is we define a secret. There it is right there. And it's called S3 credentials because it's going to be used to read my S3 storage. And it has my secret access key and my access key. I just wondered how they chose these names because they're so obviously bad.
Yeah.
That what happened was they just hacked them in, and then they really regretted it. But it's so widely used they can't change it. Anyway, that's completely off topic. But so we can put this in a secret, and then there is this general way inside inside what are called pod definitions. That's what this is right here. It's a specification for a pod, where we can basically associate these values in the secret, and what happens is they will now appear in the environment as environmental variables. So, if you use, like the OS command, for example, a common way to, is just to stick these things into your environment, and then the OS command will recognize them. It happens that the ClickHouse data warehouse also knows how to do that. And this is a general way to pass this information that will work with any pod. So this is This is pretty convenient and pretty much maps to how a lot of applications work. So now that we got secrets, we basically have a way of passing keys in. The next thing we want to think about is securing the connections, because it doesn't do any good to log in if everybody can see the data moving back and forth. In fact, in the case of ClickHouse, they can still see the passwords because they're just going to be handed in using basic auth. So what we have to do is actually encrypt the connection. So how many people here have used know how certificates work? So X509 certificates, some of you, okay. If you don't, and security, I think this is like, I would recommend that you learn how this works. So the basic idea is that you want to create a secure connection between two places. The way it's kicked off is you need to be able to pass a little bit of information that's secret between the two locations, from the server down to the client, so you can agree on keys to use for the rest of the job. That's done by the certificate and private key. So private key is something that only the server has, and it's used to encrypt. It can use to encrypt data. The certificate is contains what's called a public key, and that can be handed to anybody. And as long as the application that you hand it to uses it, it can basically decrypt the stuff that the server sends it, and also know that it only came from the server. So it's a really important principle. And then certificates, the additional property of the certificate is actually signed by somebody. In other words, it's a digital signature on it that's put on it by somebody you trust, like what's called a certificate authority, and that means the application can trust that it really comes from the server and not from some people. So every time you set up encrypted connections, you have to get this information out to the server and sometimes to the clients to talk to. So this turns out to be pretty easy. The answer is secrets again. So because there's another way you can use secrets in Kubernetes. Here what we're doing is we have a secret, it's called server certs, and it has a certificate, which is, if you've seen these things, they're just a bunch of basically UU encoded, but sort of encoded text, and so on and so forth. You just stick them in a file, and Kubernetes will read this. And then what we do, and again, this is a general way that works across sort of for any pod in Kubernetes, we can say, hey, take these files and stick them in a specific location on the operating system so that my pod can read. So this distributes them out, and if you change this secret, what will happen is Kubernetes will, sort of in due time, make those files appear anywhere that they're used. So again, a very powerful mechanism, and this now gives you the ability to have encrypted connections. Is this making sense so far? Okay, so feel free to yell if anything seems really incomprehensible or outrageous. Stop and talk about it. There we go. Okay, so let's see, what do we got? We simplified things with operators. We figured out a way to get credentials out. We figured out a way to encrypt, to get the information out to build secure connections. Next thing to do is protect your stored data. So there's a bunch of ways, many databases. Like, how many people use Oracle here? Wow, it's not very popular anymore. So are you guys using MySQL or Postgres? Postgres, Snowflake. Yeah, okay. Well, Snowflake was done by Oracle guys. So
doesn't count.
Yeah, so you're still kind of, well, the Oracle in spirit. So so most databases have a built-in way to protect data. But what we're going to do is do the real simple thing, which is just when the data gets stored on a disk somewhere, let's make sure it's turned into random bits. It turns out this is super easy to do. The first thing you have to understand, though, is how does storage actually get created in Kubernetes? Because this is one of the really cool things that Kubernetes does, is that when you create your application definition, you say you have a persistent volume claim, which is a request for, say, 50 gigs of storage on EBS. The thing is, somebody's got to make that into a reality. That thing is a storage class. which basically is responsible for, the Kubernetes recognizes as being responsible for allocating storage to match PVCs. Now, what happens is the storage class is attached to a thing called provisioner, which knows how to make storage and has for example, the access to Amazon so that it can allocate EBS volumes. But when your persistent volume comes up, or when the request hits the system, Kubernetes will find the right storage class, hand it over, and your storage. What's cool is you can make your own storage classes. That's what we're going to do. So let's, oops, back this first. So this is, I love this thing because it is so simple. You know, if you've dealt with storage, you know, like if you run NetApp, if you, if you run Parted or things like that on Linux, this stuff is all a complete pain in the butt. It's complicated, it's scary. You know, like when you're running for, when you're, formatting a drive to, become XFS. One of the things I'm always petrified is, okay, am I actually reformatting the root disk? You know, Kubernetes makes this very, very easy. This is something that, this is 10 lines. And what I've done is I've just said who my provisioner is. This is the official provisioner that you use, EKS, which is the managed Kubernetes. And the only thing, most of the stuff is pretty boilerplate, like what file system type do I have, what type of EBS, GP3, that this encrypted equals true. Simply by saying that, anything allocated by the storage class is going to be encrypted. That's pretty cool. That's 2 words. So, most stuff in IT is really hard. This is not. So, in order to use it within my resource definition for my database, I am going to have to ask. So, in our operator handles has what are called volume claim templates. These are basically just persistent volume claim definitions. And the one thing I've done is just added an extra line where I said, hey, I want this storage class to allocate the storage for me. So by adding 2 words to the storage class and 2 words to this definition, my volumes are encrypted. I love this. It doesn't really get much more easy. So, so that handles that. And what that means is what that really means is somebody mounted that, we're like at Amazon, were to look at this volume, they just, unless they somehow can get the keys. Okay, so this is not too many things so far, but it's enough that, we started with simplification and we're now beginning to make things a little bit more complicated again. So the next problem that you have, or that you want to address, is how to make this repeatable. And one of the, and this is something you want to do very, very early on, because the key to, if you've ever set up, if you do set up encrypted connections, have your own certificate authority, stamp out new certificates, distribute them out. Everybody I know can do it once, but doing it regularly on a repeatable basis, especially given that if you make the smallest mistake, things won't work. And it's not just that they won't work and they won't give you any sort of comprehensible error message. This is like really standard, so you have to automate this stuff. So this is the next thing we got to attack. So, and what we kind of like is really to have a consistent way to maybe have the database definitions or the definitions of these applications stuck in GitHub somewhere, or GitLab if you use them, and somehow have them get mapped out to Kubernetes. So this is basically GitOps, where Git becomes the repository of your configuration out in your operations system. And there's a number of ways to do this, but one that is becoming increasingly popular is something called Argo CD. Has anybody ever used this? Okay, got a couple. Yeah, I like this. It's actually kind of a cool system. What it does is there's a number of common ways that you can install applications on Kubernetes. One is just to write a manifest. That's another name for those CRDs, those custom resource definitions I've been showing, and just apply them using the kubectl. That just shoves them into Kubernetes and it works. There's a variation on that called customized, which is it's a cloud native foundation project. And what it does is it will take these manifests and it can apply edits to them. And one of the cool things about that is you can apply edits that differ by environment, like your staging environment might have little VMs that don't cost very much and cheap storage. Your production environment might have big VMs and really fast storage. And then there's also Helm charts, which are widely used. What Argo CD does is it knows about all of those, and it's able to map these definitions up in GitHub and actually apply them to Kubernetes without you really having to worry about how they got there. And that's actually pretty important because Kubernetes is, there's these varying ways of doing things, and when you're putting things together, like the database plus Prometheus plus Grafana, all the parts that are necessary to build your stack, they all install in different ways. And what happens is Argo CD basically papers over this, and you end up with a system like the following, where that person on the left, who's the developer, can build a Git project, sort of produce the application definitions, and then stick them into GitHub. And then Argo CD, you can either tell it explicitly, hey, go sync this with, like a particular Kubernetes cluster, in which case it'll read through the applications and apply them all. Or you can actually wire it up with webhooks so that when you check something in, you apply a PR, it will just automatically go and update Kubernetes. This is something that I think for security, like in our own cloud that we run, which is, as I said, Kubernetes based, we never, well, unless something is really messed up, like last Wednesday. Yeah, that was not good. We normally just, merge a PR. So we make a change, like, oh, we're going to change the VM size, that we use for, sort of backend service like Zookeeper. And then that PR gets applied, and then it just magically gets translated. So we don't touch them. This is a really, if you can get this set up, what's cool about it is then, for example, one of the things that happens in particularly when you're working with security, is you'll get a CVE or somebody will report, hey, you're not, like, you're using the wrong ciphers, you've got, like the wrong version of TLS enabled. You can just go and make a change in GitHub, check it in, and basically it will get applied automatically. So it allows you to do things fast, even when you're panicked. So it's a really powerful system. It does bring up a couple of new problems. Has anyone ever checked their Amazon keys into GitHub?
Yes.
Okay, this is you don't need to raise your hand. Just I'm here to say I did it on Tuesday night, and and I was preparing for this talk, and it was pretty stupid how I did it. I didn't check in. I didn't check in that secret I showed you. I checked in the script that generated, actually something that the script was used by the script that checked it. And I was thinking, I really shouldn't be checking this. I really shouldn't even have this in this directory because I'm going to screw up. And sure enough, I did. So what happened was within about 5 minutes, I got a call from one of our other devs down in Argentina. He said, was that you? And because he had gotten a note from Amazon, well, in fact, we all got Amazon has this godlike security team. They're watching GitHub. And so they detected this, they quarantined the keys, sent us a note, we had to, respond to it. The other thing that was interesting was that I also got an ad. So there was a company that sells a solution to this problem, and they noticed this happened. So okay, I think you can see how this could be a problem. It turns out, so you can't just check credentials into GitHub. Now, it turns out that there are a number of ways to handle this problem. I'm just going to show you one of them, which is basically implemented by something called kubectl, which I mean, you can use HashiCorp Vault. There's Mozilla has a project, SOP, I don't know how to pronounce it, but they all basically do the, sort of roughly the same thing. I like this one. This is from Bitnami. What it does is you basically take a secret, and before you pass it in, you're going to encrypt it or seal it, and you're going to create a resource called a sealed secret. And as you might guess, what it does is it just takes whatever the password, the secret value is, and it encrypts it. So what goes into GitHub is something that's they're not, people can't figure it out unless they get a lot of time and a lot of resources. And then when you check it in, or when you check it in and do your push down to Kubernetes, it arrives as a sealed secret. And what I like about this really elegant thing is there's a controller, which is a bit like an operator, and it's just looking for these sealed secrets. And every time it sees one, it will know how to decrypt it and turn it back into a secret. So this is really elegant, and just is this mechanism that works throughout Kubernetes. So that's one of many ways to deal with this problem. Second one is, now that we're getting into CI/CD, we've got to think about scanning. So and we do this a lot. So we have our own CI/CD. We do a lot of Docker, build a lot of Docker containers. There's a bunch of these out there. Two that I really like are, I love Trivy. I don't know if anybody's seen this I'm just going to sing its praises. It's totally easy to install. It's free. It will contain scan your containers. There's also Docker Scout, which for the time being is free. We run that in our CID system. It's kind of good to run them both, or to run a couple of them, because they tend to get slightly different results. And then you run these, and in fact, if you take anything away from this talk, if you're running containers anywhere, just run Trivy on them and see what it says. If there's like a bunch of CVEs marked high, think about how to fix that. Okay, so we got a bunch of, this kind of covers the database. We get to the quick part of the talk, so we're not very far from the after party. So we got all these bits and pieces, and what I like about this is I think most of these are fairly easy to use. The CI/CD integration is complicated. It takes a while to set up, but the nice thing is once you do it, it kind of stays set up. And then if you use it, it's pretty good. So let's talk about the outside the database part. So back to the threat model. So we got the database already covered. Now we got to think about protecting Kubernetes. And we got to think about protecting external data. So protecting Kubernetes, I'm going to make this really, really easy. 2 words. Work? Yes. Managed Kubernetes. Okay. This I cannot recommend enough. When we first started our journey into Kubernetes, I was thinking, being an engineer, let's pick the most complicated possible way to solve this. We will have our own Kubernetes distribution. We will, we'll install all the parts ourselves. Fortunately, we have a CTO who's, kind of slap that down. And we run EKS. We have customers that run AKS. That's the Azure managed Kubernetes. These are great. So if you're running Kubernetes in Amazon, for example, I looked up the price on EKS. It is $72 a month. That's like really, really cheap. Everything else, Amazon loves this, because then of course you run a bunch of VMs and then you get charged to the node students for those. So it's in their interest to do this, but it takes care of just a bunch of problems. Like, hey, how do I make sure that, like, Kubernetes has a database called etcd, that's the brain of it. You need that encrypted because secrets are safe. So Amazon takes care of that stuff. They take care of upgrades. They take care of it. Hey, if there's some CVE on Kubernetes in general, they fix it. There are some downsides. Like they'll upgrade stuff sometimes when you don't want to. GKE does that. But overall, this is a really, really great solution. And it just makes your life better, and it's more secure. So, when you're running it, there's just some basic housekeeping, but it's fairly easy to keep track of. So for example, you're going to get credentials to log into Kubernetes, so you want to keep those pretty safe. We use, and I don't know how we do this because this is not something I set up, but we use temporary keys to get into Amazon. They're really great. They last a few hours and then they evaporate. So those are good ways to work things. You want to shut off SSH. Like Kubernetes uses what are called workers. Those are the VMs where all your processes run. There's no reason to SSH into them. If you can't get into it with SSH, either can Bitcoin miners. Guard the network, and then there's a bunch of pretty good vendor scanning tools. The one I particularly like, OzGuard, dude. That's not very expensive. I think Amazon, this is another one where Amazon has done a really good job. It basically, you pay for the price of logging, but it will, hey, if somebody's like, inside Kubernetes and they're starting to look at, like external IPs in a strange way, you'll get a note that says, look at this. Inspector will check your VMs. Google Command Center, I haven't used much, but it's a similar product for we're just trying. And then the last thing is external data. So I think the big thing here is it's hard to give general guidance on this other than don't forget it. Databases, for example, need to be backed up. So, why bother breaking into the database if you can get the backup and then you can just take it home and install it, do whatever you want. So this is something that makes me very paranoid. They're commonly stored in object storage. Many databases, data warehouses in particular, increasingly store what we call long tail data, sort of older data where you want to have cheap storage, and stick in S3. So what that means is you better make sure that S3 has good policies on it so people can't break. Another interesting one that I think people tend to forget is how many people use centralized logging systems. Yeah, so I don't know, is LogZ still around? I mean, there's a bunch of these. Sentry does this, basically. Anybody here use Sentry? So RBC at Excel would be really disappointed. So so anyway, you're basically what you're doing is you're taking logs from the database and you're sticking them in some centralized location so that when things mess up, you can just dive in and you see the logs for the database, you see the logs for the apps, you see the logs for, like your middleware, for Kafka, for whatever data pipelines. So they're all in one place, and then you can kind of sift through them and find out what's messed up. The problem is that database messages often contain insecure things. A simple example, in our data warehouse, the ClickHouse data warehouse, we allow people to use keys to encrypt data, to AES encrypt data as they stick it into columns. But if you made a syntax error in that command that does that, it will print the entire command in the log along with the key. This is not good. So, and part of it is defective security on the part of the database, but there's other things. Any SQL commands contain a tremendous amount of sensitive data. They contain customer names, for example, because somebody might be looking up, doing a query about customer name if they somehow appear in the log. In they go. So you want to think about these sensitive messages. This is a problem where the simplest thing is maybe not to just put it in those logs at all. Maybe keep that stuff out. The other thing that we do is we implemented a feature in ClickHouse where we put regexes on. So at least if we can put some rules in to say, if you see something that looks like a password or a key, just blank it out. Just turn it into stars. So that's it. So these are things, and we have a little, oh gosh, the baby is not, wow. I spent a lot of time with it. I'm crushed. So this has been sort of a, we had this relatively simple model of, think about protecting the database, think about, protecting the enclosure Kubernetes, think about the external data. And there we go. And then you have these basic tools. And the cool thing is that I think of these operators, well, it's hard to say which one is most important. Probably operators and GitOps together and managed Kubernetes. Those are three big things that if you're just going to pick things to go after even within this list, do those. And then beyond that, just think about, hey, simplify the problem. If you can, make it somebody else's problem. That's the managed Kubernetes. And then use common sense. Just look for the obvious stuff. There's always the thing about security, as I said at the beginning, it's a multi-dimensional problem. You're always going to have stuff you can't cover. But if you can get at least the obvious stuff first and have a reasonable way of automating your procedures, you can then build in any direction. So I think that's it. Can I get to the next one? All right. Thank you very much.
Any questions?
Regarding the storage,
Yes.
or encrypting storage, you define a storage class, but doesn't that also it adds a little bit, another challenge as far as managing the key that's used to encrypt or decrypt storage?
That's a great question. So by magic.
Oh, cool.
Yes, by
Tell
Amazon.
me the magic spell, please. Thank
So
you.
Amazon does.
I want my data back.
Yeah, that's this is a really good point. Yeah, because the thing about keys is if you lose them, it's kind of like you read those stories about some guy who has 400 million in crypto and he can't. Yeah, that's the same problem. Let's go back and look at that storage class. Well, okay, this is taking a while to get back. Here we go. So what's happening here is it turns out that Kubernetes knows this keyword. It knows the fact this is something that's built into the storage model. And so if the provider knows how, and the provider in this case, or the provision I should say, which is the EBS storage driver, it will actually accept that and just automatically encrypt it. It also manages the keys. Okay. God help us if Amazon loses those keys, but this is something I don't stay awake worrying about that because we're all going to be screwed if that happens. So that's the basic answer. Yeah, I think that with encryption, the big issue that I think sometimes comes up is people worry about performance. As far as we can tell, there isn't a huge impact here. Yeah, there's some, but because the thing is, it's Amazon puts enough. They have enough horsepower and they do it low enough in the storage drivers. It seems that it's not very noticeable.
Vault is very popular.
Yes.
With HashiCorp changing the license and everyone's kind of getting a little bit talk about it. Do you have any similar recommendations?
Well, first of all, I am staying awake worried about that actually, because we're just in the middle of releasing a Terraform driver for our, so I don't know if you guys have heard it. So Terraform, it was Mozilla license. Was that how it started? I think it was Mozilla license. It's now switched to business source license for Terraform. So which says, hey, you can't use it for production environments. Well, if you can't use it for production environments, why would you use Terraform?
Yeah. So pay for it.
Yeah, you'd have to pay for it, right? Which means, we'll see how successful that is. Yeah, we are concerned about that. I think though, Vault, as I understand it, we don't use Vault, but my understanding is that actually, if you use the Vault server, you do pay for that. Is that correct?
I was just thinking that they just said going forward, every product that they have, the next release will be under BSL license.
Yeah, I think I think this is a major issue. And well, first of all, what will happen is Terraform is going to fork. It already has. So that one will get solved. I don't know what to do. I don't know about Vault, how that will be handled. I think people will just pay up for that. The other ones, I'm not sure. What it will do is give impetus to things like Argo CD. So when I look at our customers, about half of them, probably the most common way that people automate stuff is using Terraform and presumably other HashiCorp products. So I think they're going to be looking elsewhere. And this will just give impetus to things like, like Argo CD, which is a CNCF or Cloud Native Foundation project. So it will become more popular. I think we'll see forks of anything that HashiCorp has done that will be maintained probably by companies like Amazon, to be honest. So it's created confusion. I think that's the initial answer. And yeah, it's kind of worries me because we need to figure out. Not a very good answer. I'm sorry. Other questions?
Hey, so what I'm curious about is how is
I don't think it's a problem because most things encryption is something that can be parallelized pretty easily. So, you imagine you have, because what you'll do is this is me speculating. I've never written this code, but I'm just thinking about how we deal with similar problems like decompressing data. We parallelize it. So you can imagine you have blocks of data coming in, and the more blocks you have, you just farm them out to different cores on your CPU. And so as you scale up, presumably you're going to have more processing applied anyway. So you'll basically just add more resources. I don't think it's a problem. What you usually worry about is how much effect does it have on giving an answer back to a user for a particular block. And our tests don't show any really measurable effect. I mean, there is an effect there, but it's very small.
So what you're saying is like, say, Facebook when it's first.
Yeah. 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 So what it does, what's interesting about encryption is it's not going. So what you don't want is costs that, for example, kind of go like this, as like the amount of data you have is increasing like that, but your costs are going up like that. If the data size and the cost, to decrypt increase in tandem, it's not a problem, because what's happening is your business is, Facebook is growing. So they have more people on the system, the network is more valuable. So, they can afford to apply the extra resources. As I say, that I think there are other problems, at least in our field. What really chews up the database time is doing actual analytic processing, like computing histograms. Right? That's a really expensive operation when you're doing it on 40 rows. So that's the kind of stuff that people tend to use. I think there was one in the back. I want to just make sure I understand that question. So was the question how do we persuade people to use Kubernetes in these environments, for example, with dbt, with Snowflake? That's a great question. And because it's actually two parts. First of all, how do you build a system that contains a mix of services like Snowflake and Kubernetes? So that's question number one. The second question is how to persuade people it's a good thing. So we can take those one after the other. Actually, as it turns out, Kubernetes is nice because it's kind of like this sandbox that you can just throw anything into. So if you have a managed service, there's no problem for Kubernetes processes to call out users. So you can run applications in Kubernetes that call out to your Snowflake server. They don't have to be going to a local database server. They can just call, through the network. So what you do is you manage the parts of your application that run in Kubernetes. You manage the way I described, and then everything else can be managed service. And then at some time they may migrate back. Like you might have MySQL, which you're using, say, Amazon RDS or some other cloud service. When it migrates back, you then just fill out the installation, apply the security principles, and it becomes part of Kubernetes. So you can even move back and forth without wrecking your application. This is possible to do, and it's a very common pattern. So among our users, they'll have some set of services that they like. Often they'll use our cloud for analytics, and then they do their own Kubernetes. as far as persuading people that this is a good thing to do, I think that's an interesting question. Because if you already have something that's working, it's hard. But if you have new things, I think it is easier to make that argument. Some of the things that are good about Kubernetes is, first of all, it is portable. So if you build an application on Kubernetes and you're in Amazon and you decide you want to move to GCP, you can do it. You've already done 90% of the work to get there, typically. Another thing about Kubernetes is it lends itself to automation in a way that most, sort of conventional application management scripts just can't match. And that's important because as applications get bigger and as teams, have more things to do, you need to automate stuff. So those are a couple of things that I would use as, sort of reasons to use Kubernetes versus, say, God forbid, racked equipment or, sort of installing stuff, directly through the CLI interface.
And it's a healthy project.
It's a healthy project. Oh yeah, this is another thing. So Kubernetes is owned by a foundation. So, and I think as we're seeing with, the real thing that HashiCorp is raising for us is every time you see a company where there's a big open source project and it's owned by one company, you got to think at some point they're going to close. This cannot happen in Kubernetes. It's in a foundation. It's sponsored by a bunch of vendors and users. So it's a pretty safe platform for a long time. Oh, please.
So when we talk about secrets, do we assume that the secret's coming from something like AWS Secret Manager, or it's just coming from?
This is independent. Actually, you can use like Amazon services as well. I just haven't done it, so I didn't give an example.
So everything's coming from
for example, database connection. How do we decrypt it into secret?
So it disappeared. To make that, yeah, what you can do is, like in the example I gave of how we handle secrets, they actually get decrypted automatically. So there's a real secret sitting in Kubernetes. And you can dump it. So that means you do have to keep an eye on Kubernetes to make sure that people can get into it. So it's actually not that hard to debug.
All right, thank you guys
For your presentation, and if you guys have any more follow-up questions, feel free to reach them on LinkedIn.